Hey guys, welcome back to the second part of this lecture for AIT 1003. We're going to keep diving down a little bit deeper and a little bit deeper into our fluid power systems and the principles behind them. And like I said, we've been talking at a really high level at this point, just kind of general terms. But now we're going to start getting more specific, okay? So we've got a hydraulic system or a pneumatic system. We have a fluid power system, and we want it to do stuff for us. We want it to do work. Okay, that's the whole reason we got it. We don't build one or sell one or buy one just to have it. Okay, it's something. It's got a task. It's got to do. Okay, and that fluid power system has to be rated for the task at hand. Okay, before we can really start designing one and start to understand how one's built, first of all, we've got to understand some real basic principles. Okay, first of all, like I said, we want to do some form of work. Okay, and I used an example of a cylinder with a pusher arm, and perhaps you have a box that weighs 50 pounds or so. It comes down the conveyor and it's reject, so we want that cylinder to kick that box off the conveyor down to a reject bin. Okay, it's about a 50-pound box, so it's got to be able to do that work. And work, as we define it, is the movement of an object from one place to another. We talked about that in the last lecture, moving it from point A to point B. Well, that's the same thing that reject cylinder is doing, is kicking that box from, it's retracting that cylinder, and it is kicking it fully extended from point A to point B, and it just happens to be pushing a 50-pound box in its path, okay? That's the work that we are trying to do, and we measure the work that we're doing in pounds. Now, we're going through some definitions, all right? And I'll stop for just a second. This is not about memorizing words as a definition. You do need to understand that. Get your head around these definitions, because they will also translate into formulas that we're going to be using in some of our equations and our math problems, okay? So this is not just a matter of learning the words in a definition. We're going to see how this all comes together. So go ahead and start trying to get your head around this, okay? So we're moving an object from point A to point B. That's the whole purpose of our fluid power system, okay? And we, like I said, we measure that in pounds. Now, force, another definition. Force is what's required to move that object from its point of rest to that other place, to point B, from point A to point B. What's it going to take to get that arm out there and kick that box off that weighs 50 pounds, okay? So when the force is greater than the 50-pound box, and add to that the resistance of the seals inside the piston, and the resistance of the fluid and the conductors and all the things we talked about prior to, once we overcome that with enough force, then we get our work done. And this is a little file here. We've got a hydraulic ram pressed down on some sticky notes, some Post-it notes, and it's got to overcome the resistance that this block of paper there is causing it. If we just let the ram sit there with no fluid power pressure behind there, it'd just sit there, and it would not be enough to overcome the resistance that block of notepads is, or the block of paper, notepaper, is causing. In other words, it just kind of sit there. But we want our ram to go from all the way here down to the platen on the bottom, and we want to do that. We've got to overcome the resistance that this paper is creating. Okay, so like I said, force. Once we get force greater than the resistance, then we actually have work. At that point, we move from point A to point B. Okay. All right, now, in fluid power terms, we call this exerted force, okay? And here's just another example I've got for you. This is an end loader full of coal, okay? We're in Western Kentucky, so why not use that for an example, right? All right, so we want to be able to exert enough force to lift that load. Now, the resistance is going to be, obviously, the amount of the weight of coal in the end loader here, but you also have mechanical resistance there. Okay, you got a connection point right here where there's a bearing, okay, and it minimizes resistance through friction, but you still have some resistance there. You've got the seals and things like that, and the lines. All of that pump has to overcome all of that resistance in order to be able to lift this coal, all right? So we call that exerted force, okay? And this is, like I said, this is just another example. But once we have overcome all of that resistance that I just listed, then we were able to lift that end loader up with coal, okay? Now, so when we're talking about work, how much energy is required to move that object from point A to point B? Okay, that's our work, all right? And work has a formula. Work is equal to force times the distance. We talked about the force that was required to overcome the resistance of our load, okay? And how far we're going to move it, okay? Multiply force times the distance, and then that's the amount of work you have. Okay, so let me show you real quick. Okay, so we're going back to this example where we're trying to raise this load of coal. Now, I'm not going to calculate all in the resistance of our couplers and the line resistance and things like that. Okay, we're not trying to become fluid power specialists, but I do want you to understand it. But we're going to keep the example fairly simple. So I've got 4,000 pounds of coal in this scoop. Just making this up, okay? 4,000 pounds in this scoop, and I want to raise that scoop 6 feet. Now, our distance is going to be in feet, okay? And like we said earlier, our work is always going to be in pounds, okay? So with our formula that we talked about just a second ago, force times the distance, the 4,000 pounds of force that's required to overcome and make that thing raise, and we raise it a distance of 6 feet, our work the work required is going to be 24,000 foot-pounds, all right? So that's the simple formula, and you can go back in this video and back it up and get that formula down, okay? So here's another example, okay? You go to a shop, all right, and we're wanting to raise a 5,000-pound service truck on a lift, all right? So we're going to raise this thing 7 feet. So simply, the amount of work is going to be the force times the distance. It's going to 5,000 pounds of force to lift that force up, or the force required to overcome the resistance to raise that 5,000-pound truck. We're going to raise it 7 feet, okay? So it's going to require 35,000 foot-pounds of work to get that service truck up 7 feet, okay? Just another example of how to use that formula, very simple, all right? But we typically want to know how much power our hydraulic power, or our fluid power system is going to require in order for it to raise that, okay? We don't just go up and say, okay, we need to do 35,000 pounds of work. What we need to do is find out how much power it's going to take from our fluid power system to be able to do this task. So power is simply the amount of work done over a period of time, okay? Now, oddly enough, that sounds like a phrase, over a period of time, okay? I've done something over a period of 3 days or something. That's actually, you're saying the formula. That's the amount of work done over, which means divided by, over a period of time, okay? So, and we measure that in foot-pounds per second, all right? So we're going to go with some more examples, okay? And again, here's your formula. You got your power is equal to the amount of work over a period of time, okay? So we talked about the amount of work being done for this raising this service truck. That's 35,000 foot-pounds, okay? Moving forward, that's the amount of work we're wanting to do, okay? We put it over a period of time, and in this particular case, we want to say give it 12 seconds to raise it that 7 feet. So you're going to take 35,000 pounds and divide it by 12, and the amount of power required to raise this service truck 7 feet in the air. Okay, the service truck weighs 5,000 pounds. The amount of power that's going to be required to raise that is going to be 2,916 foot-pounds per second. Okay, so every second we're going to have 2,916 foot-pounds of power, okay, in order to get this service truck up in the amount of time that we want to, okay? So that is our power, but we have to express power in a unit of measure, and we do that through horsepower, okay? So we know our power because we just figured that out. There's our number right there. We just figured that out. So we have 2,916 foot-pounds per second. Okay, that's not the number we want to use in fluid power world. What we do is we take that number, the power number that we just came up with, and we divide that by 550. That number stays constant. Every time you go to calculate horsepower in this class or anywhere else, you're going to have the amount of power. Now that will vary. Divided by 550, that will always stay the same. And when you plug in our numbers that we just had, okay, I've got all the formulas up here. Stop this video at any time and take a look, and you get your formulas down, because we're going to start talking about area and square inches and foot-pounds per square inch and things like that. So it's important that we get these concepts down really early. Okay, so our horsepower is power divided by 550. 550 is constant. We figured our power was the amount of work we're trying to do, which was 35,000 pounds, over a period of time. Okay, and I think we said it was going to be 6 seconds. So T is equal to 6. And there's our work formula if we have to go back there if we have to. Okay, but we know that work is a force of 5,000 pounds being lifted over a distance of 7 feet. That's 35,000 pounds. We kind of did this formula already. And our power is going to be 35,000 divided by 6 seconds, and that's going to be 35,000 divided by 6 is going to be 5,833 foot-pounds per second. But like I said, that's not how we express it in the fluid power world. We use horsepower. So we take the amount of work, okay? We take that, or power, excuse me, take power and you divide that number by 550, that always stays the same, and it's going to require 10.6 horsepower to lift this 5,000 pound truck 7 feet in the air within 6 seconds, okay? So these are concepts that I really want you to try to work on and get your head around, okay? I tried to explain out which, what was what as far as the horsepower, power, and things like that, how we derived these variables, okay? Now, I want you to try this next one for me, okay? You can shut this off, and when I come back, I will have the answer for you in the next video. But here's what I want you to try to figure out. Again, I'm giving you the formula right here, okay? And I want to raise instead of 5,000 pound truck, I want to raise a 2,500 pound vehicle, car, truck, it doesn't matter, okay? I want to raise it 6 feet. Well, we said that was our work. That's the amount of work we need to do, okay? So 25,000 times 6 is going to give us how many foot-pounds? Well, you figure that out, okay? Once you've done that, you want to know how much power it's going to require in order to get that work done, all right? To raise that 2,500 pound car in 6 feet. How much power over a given period of time, all right? So in this particular case, we're going to say that we want to be able to lift that in 10 seconds. That's our time, okay, in seconds. There's our seconds right there. So we've already figured this out. Here is our work divided by the amount of time that we're going to ask you to do the work in, okay? After you've got that, that will give you your power. And again, power divided by 550 will be your horsepower value, all right? And that will tell you how much horsepower is required to lift a 2,500 pound car 6 feet in the air in 10 seconds. So I want you to pause the video. I'm going to shut this one down, and when I come back, I'm going to have an answer for you in lecture number 3. And if you got any questions, or if you don't get it right, back up into the previous video just shortly and kind of figure out where you went wrong. If you still can't, get a hold of me, and we'll talk through it. We can do it in person, we can do it on the phone, we can set up a Zoom meeting or a Teams meeting, whatever, and we can make this work, okay? So do that. Shut the video down, and I will see you in video number 3. Thanks for watching, and be sure to tune in just a few minutes.